Yo, yo, Algebra Maniacs! Welcome to the Johnson Ken Crow Video Hour.
But it's not an hour.
Our time is precious, though. Okay, this is Section 8.2, the reciprocal function. Reciprocal. Oh yeah, don't forget it's supposed to be fun. Reciprocal.
Flip it.
Flip it. Flip it good. So flip it is almost like the same as inverse idea. So that's kind of where this all comes from, inverse variation.
We did that yesterday.
We did.
Sweet.
You are so smart.
All right.
Okay, f of x equals a over x. What does that remind you of?
That reminds me of yesterday when we had y equals k over x, the constant over x.
Right.
Why do you think they use a instead here?
Well, it seems like all the graphing we've been doing, they use ax squared plus bx plus c, and a times x minus h.
So you're saying there's not a difference between a over x and k over x. It's just a constant over x.
Right.
Okay.
Yes. All right, let's try graphing and see what these buggers look like. So we did some numbers ahead of time, but we'll put them in still. Let's choose -3. So 1 over -3 is -1/3, -2, -1/2, -1, -1, 0.
Can I choose 0? 1 over 0 can't do it.
Oh, the world will explode if you do that. So then 1 and 1, 2 1/2, 2 and 1/2, 3 and 1/3. All right,
okay,
let's
4
try
would be
those.
1/4, etc.
All right.
I'm going to graph them. I'm going to start with -3, -1/3.
Nice.
-2, -1/2, -1, -1. What do you think is going to happen? What if I were to pick, for instance, -1/2?
1 over 1/2, you flip it, you get -2.
Okay, so it is going to be increasing.
All right, so let's do the positive ones.
Okay, so
1,
we had 1, 1.
2 1/2, 3 1/3.
And I bet this would be here.
Yep.
Okay.
So if we keep going, they're just going to get closer and closer to the x and y axes. And they make these cool little curves. Awesome.
Okay, which brings us to this thing.
Asymptotes, the boundary lines. What are we not going to cross over?
Well, I don't think we've ever done anything that has 2 asymptotes, but this looks like it has 2 asymptotes. There is a vertical asymptote here. Abbreviate with VA, vertical asymptote, and that, remember, is always an x equals equation, and that's at x equals 0. So this has got to be a horizontal, aha, y equals 0, that is the equation for the x-axis, or any horizontal line is y equals.
Okay, so now we're going to give you the general form of the reciprocal functions.
Whew, that looks kind of scary. I'm going to move these arrows a little bit so that they can see.
All right, so if you take out the h and k, we're back to what we started
Wait
with.
a minute, h and k?
That sounds very familiar.
Okay.
Wish they'd done it j and k, because that would be us.
Well, I know this goes up and down.
That's right, because k is okay, and it does positive for up, negative for down.
I know that this is the right or left one, and this is the one we all have trouble with.
H stands for help.
Yeah, we
It's
need
backwards.
help. We need help. This is the backwards one, so be aware.
So right is negative, left is positive.
Yep. And then A, what do you think A controls? In the past, it's been like a stretch or a compression.
In this case, I believe it is stretching or pushing it closer or farther away from the origin.
I'm going to call it a stretch again.
Okay, so
but we're talking about squeezing in closer or farther away
right
on the curves.
Okay, cool.
Is that all right?
Sounds good to me. So either get closer or farther away from the origin. So larger numbers get farther away. All right, so 12 is a large number, so probably our graph will be farther away from the origin than that last graph.
All right. Let's pick some points. Also, I think, especially when you have a number like 12, we could maybe make our lives easier by picking factors of 12.
Oh, heck yeah, I don't want to get decimals.
Yeah, me neither.
Decimals are the devil. Fractions
Don't
are
tell
our
them that.
friends.
They always think that anyway. All right, so let's start with something like
-4.
All right, that's -3.
Yep.
-3 is -4.
-1. 0.
Hold on, you're going way too
Sorry,
fast.
it's a 2. I missed it. 12, 6.
Yeah.
0 doesn't work again.
Right.
Can't divide by 0. Does that mean that's why our asymptotes are there?
Oh, go figure.
Asymptotes are where the world will explode. Ooh, you're good. All right, let's plot those.
All right, -4, -3.
Mm-hmm.
-2. Oops, I gotta give myself some more room. -3, -4. I skipped that one. -2, -6.
Mm-hmm.
And then 12's gonna go off the screen, but it's gonna be about right there. I think if we were to keep going, it's gonna keep curving.
Well, we could do.
Yeah, we could do
-6,
6.
-2.
Yeah, that's good. That'll give us some
Those
more.
reversed.
1, 2, 3, 1, 2, 3, 1, 2. Perfect. There's one curve. Make sure you're not crossing your asymptotes.
So if you don't hit your dots, can you make your dots bigger?
Yes, of course. You taught me that.
All right.
I learned very well. So there's 112, 2, 6, 3, 4, 4, 3, and then if we were to plug in the 6, we get 2.
Nice. All right, so you can see it is farther away from the origin. Nice dots.
I learned from the best. All right, so if we compare that, I'm just going to flash back to the other page real quick. Oh, we got to do asymptotes and domain and range. Don't let me forget.
Okay.
But look at the
Look how
red
close
curve,
that
how
is.
close. She's talking about how close to the origin this is versus the one we just did, definitely much farther away. So when we're talking about stretch and compress, that's what we're referring to.
All right, X and Y intercepts. Are we crossing those? No.
No, there are actually none. So I'm going to call that item number 1. There are no X and Y intercepts.
Okay. The VA, vertical, means up and down.
Okay, yeah, because there's 2 asymptotes. There's one right here and there's one right here. The vertical asymptote is always an x equals equation, x equals 0. And the horizontal asymptote is going to be a horizontal line, so that's a y equals equation, and they're both 0.
Okay, domain is all your X values
Well,
left and right.
Okay, that's kind of tricky. We've never had this. So if we have a domain, we're using all these x's, and we're using all these x's, and the only spot we can't have is our dotted
0.
line.
Yeah.
So what's the best way to say that, do you think?
So all the real numbers,
Uh-huh.
except X cannot be 0.
Okay, so we could maybe write words except 0, or I like to just do this.
I do too.
Yeah.
Awesome.
So then what about the range? Same kind of thing. We're
All
using
the
all the
real
y's, but not 0.
Nice. I love how mathematicians speak and write and code.
Me too. Oh yeah, I got a little reminder down here. We didn't do any of these examples, but it could happen. What do you think it would look like if the a value were a negative? So, for instance, if we had made this.
Oh, well then
All those
the
signs
points
would
would be
switch.
reversed, so it'd be in opposite quadrants. Yeah.
That makes sense.
So instead of 1 and 3, it's in 2 and 4.
Well, quadrants, we haven't talked about that in a long time.
Woo!
Alright, sweet.
I'll remember that. All right, next one. So this has got a 0.5, so that tells me it's a small number, so that tells me it's going to be very close to the origin.
Could I use a fraction to think about this?
Sure.
That would be easier.
You get 1/2?
I'm
Yes, decimals are the devil. So put it in a fraction form.
And isn't that the same as this?
It is.
That, I think, for me, that's easier. Maybe you like those double decimals.
No, I don't like decimals.
What should we choose for this? It's a little different.
Well, -1 is always a simple one.
That's -1/2.
Then, really, any number is going to work because the x is next to the 2. You don't have to worry about
It evens
getting
or
even.
anything.
So let's do it -2.
Okay, that makes -1/4, so we're getting smaller. What about something like -1/2?
So 2 times 1/2 is 1 and negative, so -1.
Okay. I think that's probably good. We know the general shape.
Okay.
Should we move on to positives?
Yeah, do a 1
Hey, these are all the same, they're just positive.
Sweet. 1/2 1.
Alright, I'm gonna graph them. -1, -1/2, -2, -1/4, and 1/2 was 1. Ooh, super tiny.
And then all the positives just do the reflection. Be careful, yeah. Don't cross the X and
The
Y
lava?
axis. The lava.
And it doesn't curve back up, it gets closer, but we have a,
Do your best.
yeah. Okay, there are, maybe I should do it.
X and Y intercepts doesn't look like they cross, so none. Asymptotes, same as before. X equals 0 and Y equals 0. And domain, same as before.
Yeah, all real numbers except x cannot be 0.
Domain, all reals except Y can't be 0. And that's going to happen every time you're on the X and Y axis like that. Let's do one that's, answer that question first, but we want to do one that's not on the origin, so we'll see.
Okay.
How does this differ?
It's closer to the origin.
Right.
Much closer. And if we compare the 3 we've done,
Way far away.
way far away, that was with an A value of 12. Closer than the 12, but farther away than the 0.5.
Right.
Alright, I think I'm getting it.
Cool.
Whoa! Whoa!
Alright, we got some extra numbers in here. So if you go back to that original y equals a over x minus h plus k.
That thing?
Right there. So we got to remember h is on the bottom and k is on the end.
Okay.
Here we go. So h is 3 and k is 2.
Okay, so this is an up. And
it's
then we always have
opposite.
trouble with this. It is to the
Right.
right 3 units.
Okay. So we can do our standard 1 over x.
Okay, those are my hints, by the way.
Okay, shape chart. So 1 over x is going to be the shape, and then we're going to slide it.
I'm going to write this for them. And we're doing all 1 over x's. We're doing the basics, guys. When you get to trig, you're going to do some more complicated stuff. But
Yeah,
for the
baby.
shifting, we're going to do all 1 over x's, which is really nice. You'll get to memorize those. Then we'll handle the shifts and make sure that you handle your 2 asymptotes and shift them.
You'll get to know
correctly.
your shift really well. Okay.
Okay, the shape is 1 over x, and we have already done that, but just a quick refresher. If we plug in -3, we get -1/3. If we plug in -2, we get -1/2. -1 is -1. And then if I...
Negative 1/2, do you want to do that one too? Just to get
Oh yeah,
through that?
okay, that's a good idea.
And
That's
negative
-2. And then we also would have the positive versions of all of those.
But we can do those in our head.
Okay, all right, I'm with you. -3, -1/3, -2, -1/2, boom, boom. And then I know this is going to be exactly the same, only reflected. And if this were our final answer, these would be our asymptotes, but I would not recommend getting too detailed here because that's not our final answer.
Right, we gotta shift it over.
Okay, there are 2 asymptotes. I think maybe we should shift the asymptotes.
And then draw this.
Yeah, so the right 3 is going to affect which asymptote?
The vertical, up
Yeah.
and down.
Yep, so this was here. We're going to shift it over to the right 3 units.
Nice.
And here is our horizontal asymptote. We're going to take that and shift it
2.
up. Let's take all the dots then and shift them to the right 3 units. 1, 2, 3, and up 2. That's kind of like my starting point, and I'm just going to sketch from there. I'm cheating a little.
That's alright. Show the work on the other one. You can cheat a little on this one. Alright, so just draw the little arrows in. Nice. And that is beautiful. Nice.
All right,
Okay.
sketch the asymptotes. We did that. Now let's talk about domain and range because it is a little different.
So it's still all the reals, but you're still going far to the right and far to the left. But this time, x can't be, where's your dotted line on the x-axis?
Oh yeah, that was the h.
Yeah.
X can't be 3.
Okay, and then still the reals going up and down as far as you can, and it can't be 2, which is the k.
Yeah, and those would be the equations for the asymptotes too. They didn't ask for that in this problem, but
So x, yeah, x equals 3 and y equals 2.
Yep.
Very nice, very nice.
Do you have anything else to do? I think that's it.
I think that's it.
Sweet.
Alrighty then. Good job, people. See you in class.
Ta-ta. Ta-ta.